Hello everybody, welcome to the Art Help session for Chapter 15. I'm Holden and I will be providing you with some resources that will be helpful for the Chapter 15 homework. I've divided these resources into 5 sections. The first will be a simple chi-squared test without importing data. Section 2 will be about importing data. Section 3 will be about using imported data. Section 4 will be getting the degrees of freedom and critical value. And section 5 will be specifying vector proportions. I've tried to roughly put this in the order that you will encounter it in on the homework. So let's jump right into it with section 1, simple chi-squared test. So if you'll notice in the instructor tips for the question, it will give you this command. I will be showing you how to use it today. So let me explain what it is first. X is the vector with data counts. V is the vector with expected proportions, and V can be inside or outside of the function. Let me show you what I mean by this. So by counts, I mean the data you observe. So let's say you observe 103, 53, and 44, for example. And let's also say the proportions we expect, so the expected proportions, are 0.4, 0.4, and 0.2. Now, how we put this into R is X, which is the counts as I said earlier, 103, 53, 44. And again, I'll specify data counts. V is the probabilities, 0.4, 0.4, and 0.2, the expected proportions. Now that we have the data, we can do either of the following. So for the purposes of this, I'll call it example. So example, we use chi-squared test, X, and P equals V. By retyping example, we can get the results from the test here. As you can read from the feedback, chi-squared value, degrees of freedom, and the p-value for the test. You can interpret these in similar ways as you could interpret the other things we learned in this class. Now, I want to show you an alternative way to do this that perhaps you may prefer. So, to do this, we would specify example again, chi-squared test, X, P equals C 0.4, 0.4, 0.2. And by retyping example, we can get the exact same thing. So the purpose of me showing you this in 2 different ways is so you can do it the way you prefer. That's what I mean with this third point. You can specify the expected proportions in the example like this, or in a different vector, doing it this way. So now let's say you've done this command. As I mentioned, example gets you chi-squared value, degrees of freedom, and the p-value. However, you can also get some other things with this. So let's say we want to see what we observed. So if we type in example observed, we get the count we observed, which we entered up here. This isn't very helpful because we already know what we observed. So something very useful though is saying what you would expect. And you would expect, if these proportions were true, 80, 80, and 20 in the same ratio as the proportions we specified. These methods are very valuable, but they only work if the data does not require importing and if you can type it out in this simple notation. However, sometimes we're not given the data in this simple notation, which is why now I'll go over section 2, importing data. You may already know how to import data because of what we've done previously in the course. However, importing the data in this fashion is quite different. So I will show you the way I find it easiest to do this. Now, go to Files, go to Documents, and if you're on a Windows computer, type Control-Shift-N. This will bring up a new folder, and you should name the folder. I've already done this, and I named mine STA because this class is STA. Now, I mention this because you're going to need to download your data to that file in order to use it. It makes it easier to find it in R so you can specify the directory. Now, let's go through exactly how to do this. Here's a problem from the homework. Press this, press open in Excel. Once the option comes up, save as, click your folder you created, and then let's name it example.data. Okay, so once we have that, we'll need to open it up because as we can see, it's in a Microsoft Excel worksheet. To do what we're about to do, we need it in Microsoft Excel, comma separated values or CSV. Okay, click Enable Editing. Next, press File, Save As, and then click this option and change it to CSV. I would like to acknowledge I realize that not everyone has a Windows computer, and if you don't, you should follow what I'm doing, except do it however you do it in a Mac or whatever other kind of computer you may have. Okay, so now we have saved it, and we've saved it in CSV format. Now you can exit out. Go back to your folder, so as you can see, back to STA, and delete the Microsoft Excel worksheet. Now we are left with the example.data in Microsoft Excel CSV format. Now you can close out of your files. Now, the next step is to type the following command. Example.data, or we can just name it example. It doesn't have to be what you named the file. As.matrix, read.csv, another parenthesis, quotation, tilde, slash, sta, slash, example.data.csv, comma, row.names equals 1. As you can see, we have imported it. Now let me explain a few things about the command. You can copy and paste this and keep it the exact same every time, but you must change this portion, example.data for me, to whatever you named the file. So when you go to your File Explorer, when you go to STA, whatever you named the file should be what you put right here in the commands. The reason why we put STA is because I named the folder that contains example.data STA. You can name the folder something else, but you must specify that right here. The other variable part of the command is this. You can name it whatever you would like. For the purposes of this though, I just named it example. Okay. So this is how you import the data. Now let's go into section 3. Using imported data. We have the data. Now, how do we do with it what we did in the first portion? Since we imported it, we can do several things. So, type chi-squared xsq chi-squared.test example. So this is extremely similar to what you did earlier. Now, similarly to what you typed earlier with example, you can type xsq and it will give you the chi-squared value, degrees of freedom, and the p-value. This is the exact same things that you get when you do it the simple way that you're manually creating vectors, except we do it this way when we have more numbers and it's more complicated than we could type with a simple vector. So that's how you get these 3 values, as I explained earlier. The next thing you can do, I'll make a note, this shows results, and we can do xsq observed. These are the values we observed, similar to how we could see these values that we observed for this. But more importantly, again, we can get expected. These would be the expected counts. This is very important as well, to know how to do both of these things, to compare observed and expected. So these are the most important things you can get from your imported data. Now let's go over section 4, getting degrees of freedom and critical value. These are important to understand, both practically how to use them, but also conceptually what we're finding with this. So to get the degrees of freedom, the generic format is 1 minus the number of rows times 1 minus the number of columns. Okay, we have the degrees of freedom formula. Now let's get the critical value formula. Critical value is 1 minus alpha, degrees of freedom, which you get from the above. Let's practice using this. Let's say our degrees of freedom is 8 and our alpha level is 0.05, like we conventionally use. So 1 minus alpha, 1 minus 0.05 degrees of freedom. This will be your critical value. Let's look at something very quickly. If we go back to the example data, we have 1, 2, 3, 4, 5. We have 5 rows, and we have 1, 2, 3 columns. 5 minus 1 is 4. 3 minus 1 is 2. 4 times 2 is 8. When we go back to our results from this test, the degrees of freedom is 8. That's how you compute this. So 5 minus 1 is 4, 3 minus 1 is 2, 4 times 2 is 8, which is the degrees of freedom. I show you that so you know how to. I actually wrote this backwards, my apologies. There we go. That's how you get the degrees of freedom, and it's also shown with this. This is how you're getting it conceptually, though, so you understand what the calculation is. Now, lastly, I want to go over something that you will encounter in one of the questions on the homework, specifying the vector of proportions. How to do it is in the instructor tips, and some of you may intuitively understand, but I want to go over it just so you don't struggle with it or spend time trying to find it. So the command you're given is chi-squared dot test data count p equals rep 1 out of 10 comma 10. With this, there is no data import in CSV needed. You simply import it the way you conventionally import stuff. File, import data set from Excel, whatever you download, name it and import it. But that is only for this. For everything else, you must change it to a CSV and import it in the manner that I showed earlier. I hope you find this video helpful, and please come to office hours. The times are specified on the syllabus if you have any questions or need any additional help. Thank you.